Okay, so the problem I posted conveniently in the upper left corner is Avi and Harry agreed to meet at their favorite restaurant between 5 p.m. and 6 p.m. They have agreed that the person who arrives first will wait for the other only 15 minutes before leaving. What is the probability that the two of them will actually meet at the restaurant, assuming that the arrival times are random within the hour? Express your answer as a common fraction. Okay, so in this problem, we're going to use something called geometric. Oh, that's a horrible name. Geometric probability. Which sounds complex, but we're just really drawing a picture. Okay, so in this problem, we're going to say Avi is the x-axis, and Harry, spelled strangely with an I, is the y-axis. Okay, so let's just draw our axes right here. So, x and y. Okay, so we know it's between 5 p.m. and 6 p.m. And so, we'll call 5 p.m. 0 and 6 p.m. 1, but instead of using 1 hour, we'll use 60 minutes. Okay, I'll draw these equations right here because these are going to be our bounds. So we know the solution is right now is going to be somewhere in this area. But we have one more constraint, and that is they'll have to meet within 15 minutes of each other. They'll have to overlap at some point. And so the difference between the times, or let's see, there's a better way to say this. The Avi's time minus Harry's time must be less than 16. Well, 15, sorry. 15. But also, we can do this in the other direction. So, let's say y minus x is smaller than 15 also. We can write this as an absolute value, but that's just a simple way of thinking about it. So, we're going to try to graph these two equations, so we'll put both of these in terms of y. So this one, we'll add y to both sides and subtract 15. So we'll get x minus 15 is smaller than or equal to y, and y is smaller than or equal to x plus 15. So we're going to graph both these equations on this horribly drawn axes. So we know that the slope is 1 and that it has a x-intercept at 15, 0. So this first equation right here is going to be somewhere right here. And it's going to be x, so it's going to be looking something like that. And this other equation is x plus 15. So we're going to start at 15 right here. And we're going to go the same slope up there like that. So we know that the answer, the solution area, is in this little section right here, which I have shaded in. Okay, so to find this area, we'll instead find the areas of the triangles around it. So we know that this is 15 right here. Both these are 15. So these lengths right here, these triangle side lengths, are 45. And then both of them together is a 45 by 45 square. And so the area of these two triangles is 45 squared. But because it's a probability problem, we'll take it out of the whole square. So that'll be over 60 squared. And we can rewrite this as 45 over 60 squared, which will then easily be simplified by dividing by 15 to 3 over 4 squared, which is the same thing as 9 over 16. But this is not actually our answer. This is the probability that they won't meet, which is kind of high. If I were them, I'd, make the time a little longer, but that's just me. So, and this, we'll subtract this from 1 to get our final answer, which is only a 7/16 chance they will meet.